Hey, it's Caroline again. Today I'm going to be talking about demultiplexers. So first to review, let's look at the truth table for a multiplexer. This is the 8-to-1 multiplexer, so we've got 3 selectors, S2, S1, and S0, and then we've got 8 inputs, A0 through A7, and then that's going to give us an output, which is then determined by whatever the A0 through A7 inputs are. So for example, if we had an input of S2 being 0, S1 being 0, and S0 being 0, then the output is going to be whatever A0 is. For example, if A0 is high, then the output Z would then be high also, because that's what A0 was. So each of the inputs, A0 through A7, each get to control what the output is one time, based on the combination of the selectors. A demultiplexer is the opposite. The A0 through A7 are the outputs. And before, where there was one output, usually high or low, this time there is only one input. And in our case, that'll be either high or low. So if the selectors are all 0 in this case, then if the input is high, then A0 will show high, and so on and so forth for each of the options in the truth table. Okay, so we'll move on to the chip itself. Right now I've got it hooked up to an Arduino, just using the Arduino as a power source because I just have it connected to a battery, so it's just giving me power and ground right now. All of my selectors and inputs right now are just grounded, and then I can manually move them back and forth, so that's a good way to check. I have it labeled just like it was on the data sheet right now. So in yellow are my selectors, blue is my input A, then I've got all of the outputs A0 through A7 in green here. And then I've got ground, so that goes to ground obviously. VEE, which is my negative power supply, is going to also go to ground. And then right now my enable is going to go to ground because I want this to act like a demultiplexer. If I wanted to use the chip as a multiplexer, I could just put that to power. And then VCC is just my power supply for the chip, so I've got that going to power. Alright, so again, my recommendation is just use color-coded wires for everything and label all of your pins, so that'll help you keep it organized. And now we'll go through and test the truth table. So if I've got all of my selectors at 0, which I do, and then let me move my input to power. So when I do that, this guy lights up. Which one is that? That should be A0. Let's just double check. Yep. So A0 lights up. Alright, so if I wanted to do that using the Arduino, I would just have these 3 selectors going to pins over here, and then I would just write low to each of these, and then I would write high to my data, and then that would give me the output that I wanted. So you can control each of these to go through each of these combinations, and then that'll just control your outputs, giving whatever the input is will be passed through to the output. So in this case we're just doing digital, but we could use that actually as an analog, so whatever was coming through the data input would just be reflected onto the output. So I don't have to use LEDs, I could use all kinds of different outputs. Maybe I have a motor or something connected. Anything's possible. So, if you're thinking in the future you want to do something cool, you could use one of these chips and use only a few inputs to control a lot of outputs. So it'd be really useful. Alright, thanks for watching, guys.